In this video, I will show you how to identify open intervals on which function is increasing or decreasing. We will do this by finding the interval where function derivative is positive or negative. Let's define increasing function. A function f is increasing on the interval ab when as we move to the right, its graph moves up. More specifically, a function f is increasing on an open interval ab when if for any two numbers x1 and x2 in the interval, so these x1 and x2 in the interval ab implies f of x1 less than f of x2. Decreasing function. A function f is decreasing on an interval ab when as we move to the right, its graph moves down. More specifically, a function f is decreasing on an open interval ab when for any two numbers x1 and x2 in the interval x1 and less than x2 implies f of x1 is bigger than f of x2. So here are the steps to find the interval on which function is increasing or decreasing. So let's say f be a function which is continuous on the interval ab. So step 1 is find the derivative f prime x. Number 2, find the critical numbers of f as follows. If f prime x found in step 1 is polynomial, then set f prime x equal to 0 and solve for x. If f prime x is a rational function, then set both the numerator and the denominator of f prime x to 0 and solve for x. The x values that are in the interval ab and f of x is defined are the critical numbers. So if any number where f of x is not defined and outside the given interval, then that x value found in these two steps is not critical number. Step 3. Form the open intervals using the critical number found in step 2. Determine the signs of f prime x for each interval found in step 3. And then step 5, use the signs of prime x to decide about the intervals where f is increasing and the interval where f is decreasing using the following rules. F is increasing on the interval where f prime x is bigger than 0. F is decreasing on the interval where f prime x is less than 0. So here is an example. Find the open intervals on which function is increasing or decreasing. The function is h of x equal to 12x minus x cubed. So let's start with h of x equal to 12x minus x cubed. So now we differentiate this function with respect to x. So h of x becomes h prime x, and 12x becomes 12, and x cubed becomes 3x squared. Now we set h prime x equal to 0. So we have a 12 minus 3x squared we set to 0. Now we're going to solve for x. So in this case, let's see if we can factor 3. And you have 4 minus x squared. Now you can factor 4 minus x squared. And that gives you 3 times 2 minus x, 2 plus x. Now we set each factor to 0. So 2 minus x equal to 0. And then x will be x equal to 2. And if you set 2x plus x equal to 0, and that will give you x equals to negative 2. Now the critical numbers are negative 2 and positive 2. Now we write the open intervals. Well, we start with negative infinity, and then smallest of these number, negative 2. And then negative 2 to next critical number. And then comma from 2 to infinity. Now we're going to test negative infinity to minus 2 for increasing or decreasing. So you can pick any number in the interval minus infinity to minus 2. Pick x equal to minus 3. You can pick x equal to minus 4. But you cannot pick x equal to minus 1 because minus 1 is bigger than negative 2. So in this case we picked x equal to minus 3. So now I'll substitute x equal to minus 3 in the first derivative h prime x, 12 minus 3x squared. So this becomes h prime of 3 equals to 12 minus 3 times negative 3 squared. So it will be 12 minus 3 times 9, 27, which is negative 15, and that is less than 0. Since h prime 3 is less than 0, so we'll say h of x decreasing over the interval negative infinity to minus 2. Now we test negative 2 and comma 2 for increasing, decreasing. So we pick any number in interval minus 2, comma 2. Well, I can pick x equal to 0. You can pick x1, or we can pick x equal to minus 1. So you pick any number which is easier, simpler. So I picked 0. So now we substitute x equal to 0 in the first derivative. H prime of x equals to 12 minus 3x squared. So this becomes h prime of 0 equal to 12 minus 3 times 0 squared. So be 12 minus 0 equal to 12, which is greater than 0. Since h prime 0 is greater than 0, we can conclude h of x is increasing over minus 2, comma 2. Now we're going to test the interval 2 to infinity for increasing, decreasing. Pick any number in interval 2 to infinity. I can pick x equal to 3. You can pick 4, 5, whatever you like. So let's see. When x is 3, we substitute in the first derivative h prime of x equal to 12 minus 3x squared. So this becomes h prime of 3 equal to 12 minus 3 times 3 squared. 3 squared is 9, 9 times 3 is 27. So this becomes 12 minus 27, which is negative 15. Since h prime 3 is minus 15, which is less than 0, we can conclude that h of x is decreasing over interval 2 to infinity. Now we put all the answers together, and the final answer is decreasing over minus infinity to minus 2, 2 to infinity, and increasing over 2 to infinity. Another example, example 2, find the open intervals on which function is increasing or decreasing. The function is y equals to x times square root of 16 minus x squared. So let's start with y equals to x times 16 minus square root of 16 minus x squared. Let's rewrite this as x times 16 minus x squared to the power 1/2. Let's first find the domain. The domain is negative 4 to positive 4. Now we find the first derivative using product rule. So y become y prime, and so here it would be x times derivative of the second function plus 16 minus x squared to the 1/2 derivative of the first x. Now we bring down x, and then we apply the generalized power rule, bring down power 1/2, and write 60 minus x squared, subtract 1 from 1/2. And then time the derivative of the inner function, which is 16 minus x. So that's the chain rule. Plus this rewrite 16 minus x squared to the 1/2, and the derivative of x is 1. Now just bring down x in 1/2, subtract 1 from 1/2, so it will be negative 1/2. And here the derivative of 16 is 0, the derivative of x squared is 2x. Plus 16 minus x squared to the 1/2 times 1 is 16 minus x squared to the power 1/2. And now simplify further, so you can see x multiplied with x becomes negative 2x squared, so 1/2, and just bring down using the negative exponential rule on the denominator, and plus 16, and x simplify. So after we simplify, we get y prime equals to negative x squared over 16 minus x to the 1/2, and plus 16 minus x to the 1/2. So find the LCD. Well, LCD is 16 minus x to the 1/2. So we rewrite minus x squared over 16 minus x squared to the 1/2 plus 16 minus x to the 1/2, multiply top and bottom with the LCD. Now we simplify. Well, just we copy this down, minus x squared over 16 minus x squared to the 1/2 plus we multiply these two. See, we're using the product rule of exponentials, same basis, so we add the powers. 1/2 plus 1/2 is 1, so this becomes 60 minus x squared over 60 minus x to the 1/2. We have same denominators now, so we write the denominator and we add the powers, add the numerators. So we negative x squared plus 60 minus x squared. So you become 60 minus 2x squared over 60 minus x squared to the 1/2. Now this is a rational function, so we're going to set the numerator and denominator 0. So we set the denominator to 0, 60 minus x squared to the 1/2. So we can square both sides, so it becomes 60 minus x squared equal to 0, factor and solve for x. So the factors are 4 minus x and 4 plus x, which gives the x equal to negative 4 and x equals to 4. So we set the numerator 60 minus 2x squared equal to 0. And let's solve for x. Take the 16 to the right, becomes minus 16. Divide by negative 2, becomes x squared equals to 8. So now we take the square root of each side, so x squared becomes x, and this becomes plus and minus square root of 8. We can simplify plus and minus 2 times square root of 2. Critical numbers from the smallest to largest are now negative 4, negative 2 square root of 2, 2 square root of 2, and 4. Now we write the open intervals. So the open interval will be negative 4 to negative 2 square root of 2, negative 2 square root of 2 2 square root of 2, and then test 2 square root of 2 to 4. So we have 1, 2, 3 intervals. So now we're going to test the intervals for increasing and decreasing function. So let's test for increasing, decreasing over this interval negative 4 to negative 2 square root of 2. We pick any number in the interval negative 4 comma negative 2 square root of 2. You can pick negative 3. So now we substitute negative 3 in the first derivative. 60 minus 2 x squared over 60 minus x squared to the 1/2. And this becomes 60 minus 2 times negative 3 squared over 16 minus 3 squared to the 1/2. So this becomes 16 minus 9 times 18, and it becomes 60 minus 9 to the 1/2. So this becomes 60 minus 18 minus 2, 60 minus 9 is 7, so 7 to the 1/2. Now this is negative, so we can conclude y is decreasing over negative 4 comma negative 2 square root of 2. So now we test the second interval from negative 2 to square root of 2 to comma 2 square root of 2 for increasing and decreasing functions. So let's pick any number in the interval. So you can pick, looks like a 0, because 0 is between these two numbers. So we substitute actually 0 in the first derivative, which is 60 minus 2x squared over 60 minus x squared to the 1/2. So this becomes 60 minus 2 times 0 squared over 60 minus 0 squared to the 1/2. So we simplify, the top number becomes 16, and you have 16 to the 1/2, which is 4. 16 over 4 is 4. 4 is bigger than 0. So we can say if the y is increasing over this interval negative 2 to square root of 2 comma 2 square root of 2. Okay, so now we test for increasing, decreasing over this interval 2 square root of 2 comma 4. So pick any number in the interval. So it looks like we can pick 3. So we substitute 3 in the first derivative, which is 16 minus 2x squared over 16 minus x squared to the 1/2. So now we substitute and becomes 60 minus 3 squared or 60 minus 3 squared to the 1/2. So 3 squared is 9 times 18, so it's 60 minus 18, and you have 60 minus 3 squared is 9 to the 1/2. So we have negative 2 over 7 to the 1/2, which is again less than 0. So we can conclude the y is decreasing over the interval 2 square root of 2 comma 4. Now we write the final answer, decreasing over interval negative 4 comma negative 2 square root of 2 and 2 square root of 2 comma 4, and increasing over -2 square root of 2 comma 2 square root of 2. So on the web sign, instead of putting and, you can put comma here. And that's the end of this section.